Okay, first question I think should be quite straightforward. There are two solutions. There's one, there's the easier solution. I'll go through that. And then there's also one that is probably so-called like the more optimized solutions, which I will not go through, but I'll send I'll roughly give an idea. I'll send a solution if you all want to explore the more optimized solution. So get special median. So they'll give you an n, where n is like so-called the number where like this whole sequence stops. So if we look at how the sequence is supposed to be formed, let's say the number is 4, then it's just kind of go from like 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. So that number represent how many times it's repeated. Alright. Then after that, we can kind of see that there are going to be two cases. One is when there's odd number of characters. So if I put n equal to 1, there's only one number. Or n equal to 2, there's 3 numbers because 1, 2, 2. So in those cases, you just take whatever that's in the middle. But for things like even digits, so like n equal to 3, so it's 1, 2, 2, 3, 3, 3. Then you take the two middle numbers, add them together, divide by 2. Straightforward. So the way that we'll approach this question, there are generally two ways. So the one that's recommended in probably what you see in the solution, it's going to be the much more straightforward. The much more straightforward one, which actually you just create the whole sequence, and then you find the middle position, and then tada. So creating the whole sequence is going to take me first finding out what is the total length, so I know how much space to allocate for the array. So to do that, because we know that the thing is going to be n equal to 1, that's going to give me 1. But in the case of n equal to 2, that's going to give me 1, 2, 2. And then for the case of 3, for the case of 3, I'm going to have 3 more. So you can see that actually the length is actually equal to the arithmetic sum, what you learn in 104, of the n, so which is summation of 1 up to n. So you can see that this is actually just equal to 1, this is equal to 1 plus 2, and this is equal to 1 plus 2 plus 3. So we can just write a simple function for arithmetic sum, arithmetic sum, and in this case it's just going to be 1 n plus n my 1 plus n, you plus the last number, and then after that you multiply by the number of pairs, which is n over 2.0. Yep. So 2.0. Yeah, don't really need a 2.0. Okay, so that will be the arithmetic sum, and once you have the arithmetic sum, you can kind of get the length of the total number of array. So in this case, did they say what is the maximum? It will never be more than 100,000. Yeah, so you can kind of still put it in because you know that the in max is 1 plus arithmetic sum up to 100,000. I don't believe it will exceed. Will it exceed? If you want some sanity check, then you just put long. But honestly, I don't think it will exceed. So arithmetic, the length or the total is equal to the arithmetic sum up to n. So with that, you can now allocate an array. Allocating an array of whatever that total length is, and then you can fill in the array, right? So filling in the array is really just do a for loop of number up to n, and then for every number that you have, you're actually gonna fill that in 888 0. Yeah, you're gonna fill that in to the array. So in this case, array of index plus plus is equal to, or you don't like to combine to one line, you can just put and then I can say index plus plus. So with that, then you kind of fill you kind of fill out the whole array already. So if you want, you can print out the array over here. You can try to print out the array to do a quick sanity check. If not, usually that should already give you the 1 1 2 2 3 3 3 and so on, right? So this kind of already give you that structure. Now with this, all you really need to do is find the middle point. The middle point here is quite straightforward to find, but we need to handle two cases. We need to first check whether total modulo 2 is equal to 1. In this case, this is the one with odd numbers. And then after, in the other case where this is even number, we need to plus the number and sum them up together. So odd number, how can we get the middle point? What do you all do? Anyone?
Sum them together, then average.
Sum them together, average. For the odd number, how do you get the middle point, the middle index?
You minus 1. Minus 1.
Minus 1?
Yeah.
Minus 1 divided by 2?
No. It's like you get the median position, then you add.
Yeah, so what is the middle position? How do you get the index of the middle position?
You get the index of the middle position, right? Now you know that it's an odd number. You do. For me, I did count divided by 2 because I have a counter pointer.
You have a counter pointer.
But because this is an arithmetic sum, right? You just divide by 2 first. So arithmetic sum divided by 2.
Alright. So actually all you need is just arithmetic sum, which is array total divided by 2. Because integer division is gonna help me to do that rounding. So let's say, for example, if it's 3 divided by 2 is gonna give me 2. 3 divided by 2 is gonna give me 1. So which is already a middle position. You can go on and try different numbers. This will always give you the middle position if this is a odd number. Okay, and then that's all. Yeah, that's all. So then after that, then we just have to handle the case for the other one. So in the case of the other one, you need to take the left position and the right position. So you can kind of play around with the numbers. So usually you start from like a small even number, so something like 4. So then you can say 4 divided by 2, what do I get? I get 2, right? So I will kind of get the one on the right. So then after that, for you to get the one on the left, it's just minus 1 divided by 2. Minus 1. And then divide by 2. Plus array of total. Total divided by 2. And then after that, you can just take both of these. Yeah, actually you don't need the float here. You can just divide by 2.0. And that should kind of fix all your problems. And that should be the solutions. So if we were to run /a.out, bang. Oh, not so. Let me see. Did I miss something?
You didn't do a check if there's 0.
Oh. Yes, and our 0 check. So n less than or equal to 0, and then I just need to return 0.0.